In this video, we're going to apply the substitution method to solve some definite integrals. We have the integral from pi squared over 16 to pi squared over 9 sine root x times cosine root x divided by root x integrated with respect to x. So let u be equal to sine root x. Then du, the derivative, is going to be cosine root x times the derivative of root x. That's going to give us 1 over 2 root x, applying the chain rule, times dx. All right, we have to change the x limits to u limits. So we have x is equal to pi squared over 16. Plug it into u. U is equal to sine root x. So we get u is equal to sine of root of pi squared over 16 is pi over 4. Sine of pi over 4 using the special triangle is 1 over root 2. Let's draw the special triangle for that case. We have the 1, 1. Root 2 is the hypotenuse. And the angles are 45 degrees. Pi over 4. Pi over 4. Alright, let's look at the upper limit. X is equal to pi squared over 9. Plug that into the substitution. U is equal to sine root x. And we get u is equal to sine. And root of pi squared over 9, that's just going to give us pi over 3. Sine of pi over 3 is equal to opposite over hypotenuse. That's going to be root 3 over 2. So we have transformed the limits. So basically what we have is integral from the lower limit is going to be 1 over root 2. The upper limit is going to be root 3 over 2. And u is equal to sine root x, so that's going to be u. This part here is u. And this part, cos root x over root x dx, this part is going to be 2 du. This is 2 du. So times 2 du. Alright, so what we have is integral sine root x times cosine root x divided by root x dx. And our substitution is u is equal to sine root x. This is u. And cos root x over root x dx. This part here, all of this, is 2 du. And we also transform the limits. So we have integral from 1 over root 2 to root 3 over 2. U times 2 du. 2 is a constant, it passes through the integral, so we just get 2 integral u du. Lower u limit is 1 over root 2. Upper u limit is root 3 over 2. Let's integrate this, and we get 2 u squared over 2 from 1 over root 2 to root 3 over 2. The 2's cancel out, and we get root 3 over 2 all squared minus 1 over root 2 all squared. And that works out to 3 over 4 minus 1 half. Taking common denominator, 3 over 4 minus 2 over 4 is 1 over 4. This is the answer to the definite integral. Alright, let's look at another question. Here we have integral from 1/4 to 1/3 sine of pi t times sine of cos of pi t integrated with respect to t. We're going to let u be equal to the inside function, this part, cos of pi t. What is the motivation for that? Notice the derivative of cosine is sine, so that way we get part of the integrand. So du is going to be minus sine, derivative of cos is minus sine of pi t, keep the inside intact, times the derivative inside, that gives us pi, multiplied by dt. Now we get negative 1 over pi. Du is equal to sine of pi t dt. Alright, let's change the t limits to u limits. The lower t limit is t is equal to 1/4. Plug that into u is equal to cos of pi t. That's going to give us cosine of pi over 4. And cos of pi over 4 is going to be, using a triangle, is going to be adjacent over hypotenuse. That is 1 over root 2. Now put the upper t limit in, t equals 1/3. Plug it into u and get the corresponding u limit. Cosine pi t Plug in t equals 1/3. That gives us cosine of pi over 3. Cos of pi over 3 using the triangle above is going to be adjacent over hypotenuse. That's 1/2. So now we can see how the integral has been transformed. We have integral from the lower limit, which is 1 over root 2, to the upper limit, which is 1/2. And this part of the integrand, this part, sine of cos of pi t, that's sine of u. And sine of pi t times dt, this part is going to be negative 1 over pi du. So let me write it in like this, and that's going to be negative 1 over pi times du. All right, so we have sine u times negative 1 over pi du. Negative 1 over pi is a constant. It passes right through the integral. So let's pass that through, and we get negative 1 over pi integral sine u du. And let's put these u limits in here. We have 1 over root 2 to 1 over 2. So what we have is the integral from 1/4 to 1/3 sine of cos of pi t, that's sine u, times sine of pi t dt, that was transformed to negative 1 over pi du. That's equal to negative 1 over pi. Then we transformed the limits as well. So the t limits became u limits. We get 1 over root 2 as a lower u limit, 1/2 as an upper u limit, sine u du. And we integrate this. We will get negative 1 over pi. Integral of sine is going to give us minus cosine u. Evaluated from 1 over root 2 to 1/2. The negatives cancel out. We get 1 over pi cosine u. So the answer is going to be, and evaluate this using the fundamental theorem of calculus, 1 over root 2, 1/2. Let's put the 1 over pi in the front and bracket this. We get cosine of 1/2, plugging 1/2 into the cosine function, minus cosine of 1 over root 2. This is the answer. All right, thanks.